Today's topic is going to be simplify radicals with the quotient property. And the question we're going to ask is, how do I simplify radicals or radical expressions using the quotient property? Okay, recall, a radical expression is in simplest form if there's no perfect square factors other than 1 in the radicand, no fractions are in the radicand, and no radicals appear in the denominator of a fraction. So that means you cannot have a radical sign in the denominator. All right? Now, how are we going to work with this? We're going to use the quotient property of radicals. Okay? And that states that the square of a, the square root of a quotient equals the quotient of the square root of the numerator and the denominator. Okay? Algebraically, what does this mean? If you take the square root of a over b, you have the square root of a over the square root of b. Okay? Where a is greater than or equal to 0 and b is greater than or equal to 0. Steps. We're going to use the quotient property to separate the numerator and the denominator. So what that means is we're going to use the quotient property. So like on this one, where you have one large square root, we're going to have the square root of 16 over the square root of 25. That's what the quotient property says that we can do. Okay? You're going to factor using perfect squares. And then we're going to simplify. Okay, so let's look at the first couple here. So let's separate this out with the quotient property. The square root of 16 over the square root of 25. What is the square root of 16? 4. Square root of 25? 5. You're done. Okay, next one. We're going to separate out as the square root of 13 over the square root of 100. Can I do anything with the square root of 13? No, it's a prime number. So we're going to leave it as the square root of 13 over, what's the square root of 100? 10. Square root of 13 over 10. Okay, now, can I have a radical in the numerator? Yes, I just cannot have one in the denominator. Okay, so let's look at this one. Let's separate this one out. Square root of 7 over the square root of x squared. Can I do anything with the square root of 7? No. So I have the square root of 7 over x. Great job. Okay. Here, square root of 1 over the square root of y squared. Square root of 1 is? 1. Square root of y squared is? Y. All right. So let's look at this one. Okay. We're going to, it's already separated out. So we have, equals 3. Now 20. What goes into 20? If we're talking about perfect squares, 4, 9, 16, 25. 10 and 2. 10 and 2, but let's do perfect squares. 4 and 5. And that brings up a good point. I have some students that say, Ms. Shades, factoring is a lot easier. Okay, so let's do this. You can say 20, and you can factor it out. 10 and 2, 10 and 5. Or 2 and 5. So then you have to think, okay, do any of these multiply to give me 4? Do any of them multiply to give me 9, 16, 25? Well, those two would give you 4. So you would have 4 and 5. And that would bring you back to your perfect square factors. So if you want to do that method, you can use that also. Okay? And this is going to be over 2 square root 4. So let's separate this out. All right. I can't do anything with my 3. Can I do something with the square root of 4?
Yes.
Yes. What does it become?
2.
That becomes 2. Can I do anything with the square root of 5? Can I do anything with the square root of 4?
Yes.
What does it do?
Becomes 2.
Becomes 2. Okay. So we actually have, what is 3 times 2?
6.
6 square root 5 over 4. Now, can we simplify anything? Yes, we can simplify these numbers right here, which is going to be 3 square root 5 over 2. Okay? All right. Separated, it's already separated out. Can I do anything? I guess I don't need that if it's separated. So let's write that out so we save a step. Okay. So if we use our perfect squares, what does it give me? 4 times 2. And what's square root of 100? 10. So then we can do square root of 4 times square root of 2 over 10. Can I do anything with the square root of 4? 2. It becomes a 2. So my answer that I have is 2 square root 2 over 10. Can I simplify it down any further?
Yes.
Yes. To what?
1 over 5.
Yep. You can put the 1 in front if you want. So 1 square root of 2 over 5. Okay. What do you notice about the denominator? All these denominators. What do you notice about all these denominators?
They all square root to a perfect square.
They are all perfect squares. You're exactly correct. They are all perfect squares. So when they're all perfect squares, you don't have to worry about that radical in the denominator, correct? Mm-hmm. Okay. Now, what happens if the denominator is not a perfect square? Well, you must rationalize it. Okay? Rationalizing the denominator